Yes, we are. Excellent. My name's Evan Anderson. I'm currently working at Stacklok, but previously I've worked at VMware on the Tanzu product and on Google Cloud. One of the things I'm known for is being the founder of the Knative project, or one of the founders of the Knative project. I want to share the credit because it was really a big team effort. So I have opinions about custom resources, having been doing them since shortly after they were renamed third-party resources, or from third-party resources. And why is my clicker not working? Yes. And I drop in on various CNCF projects, so I've seen a bit of things out there, and this is largely derived from stuff I've seen and experienced. And as we go through these, I'm going to highlight which things are easy to just drop in and help fix on a project, and which things are stuff that you may need to talk to the maintainers to really get stuff going forward. But first of all, this is a UX talk for people who are writing Kubernetes operators. And that's kind of a weird thing to say, because Kubernetes operators aren't really known for great UX. And there's lots of open source projects that don't have great UX and have still been very successful. The UX for Git, if anyone really loves it, I'm sorry, but it's bad. Linux's UX is weird and mixed, and you can see all the strata and layers of stuff. Why does Kubernetes matter? Well, because this is where developers, hopefully, are coming to actually live and work. And hopefully, they'll find it a friendly and welcoming place, like we find KubeCon a friendly and welcoming place. Furthermore, this is where operations happen. And the worst thing when you're under stress is having to think real hard rather than having clear, obvious solutions. One of the things I was talking about with someone earlier today was feature flags. If you have a feature flag that says, avoid bug foo, do you want that set to true or false? You have to think for a moment. So having clear interfaces for operating our systems is really important when things go wrong. And when things go wrong is the time that it's most important. So think about it all the time so that when things go wrong, everyone is happy that it was quickly resolved and that there weren't mistakes that made it worse. We're going to start with a bunch of basics if you're writing a custom resource. If you've never written a custom resource before, there's a bunch of tutorials out there, and they'll fill in some of this for you. But I'm going to give you a little bit more color than just, you need to have a status. Status is really where your controller, whatever you're managing, tells the rest of the world about what's going on. And sometimes you're telling a machine, and sometimes you're telling a person. And so you want fields for both. So, we have the really simple example here. Oh, you asked for 4 replicas. I've only got 2 right now. One thing I'd criticize right away, is this healthy replicas or total replicas? Maybe you need a little bit more detail. But also, maybe you want a description for a human that says, why are there 2 when I asked for 4? Descriptions, sentences, here's what's going on here are all for humans. And then machines want like an enum. What's the status of this? Is this degraded? Is this working? If I sent a request to it, would I expect it to go or not? That's all stuff you should be looking to put in your status. And in both cases, references to other Kubernetes resources can be helpful. And we're going to look at a few examples here. So an Argo application has a status that tells you, that's this middle one here, that tells you, hey, everything is in sync. I've applied all the stuff you want. But it also gives you a list of all the resources it created. So you can go and track those down and figure out, okay, these are all the things that this application controls. A Knative service, I'm going to pick on Knative a bunch because I worked on a lot of this stuff, will tell you the URL that you can use to reach that service. So you say, hey, deploy this thing, and it comes back and it says, here's where you can reach it. It would be great if we had more resources that gave you that kind of, here's where you can go to do this right away. It also tells you the revision that is currently ready. Maybe you have future ones that aren't working, and it'll give you some information about that too. But and then if you look at Cert Manager, they have things like when your cert is valid for, that you might want to know, that you don't want to have to go crawl around for. They give it to you right up front. So these are some good examples. And you'll see there's also conditions, which we'll talk about a little later in the Cert Manager. Argo and Knative also have them, but I cut out a bunch of stuff. Often status is at least as long as the spec. Humans write a short thing of this is the thing I want, and then we have computers expand it out into a big long thing. Sometimes we do that deterministically and we call it controllers. Sometimes we do it non-deterministically and we call it LLMs. But in any case, you know, computers are ways for us to write short things and make big things out of them. And so status is great, and sometimes it doesn't make sense to have status. And so when that happens, you don't have to include it. It's not a Kubernetes rule that you have to have a spec and a status. And sometimes you're defining configuration for something else. And that configuration on its own doesn't affect anything. It's only when you wire it into something else. And so something like a gateway class or a storage class says, hey, when you create a persistent volume, when you create a gateway, use this implementation, and here's the parameters to use. When you create that gateway, it will have a status that says, oh yeah, I provisioned that stuff. Or, you know, hey, I wasn't able to provision that because you don't have quota for, you know, that type of disk. That's where the status goes for those classes. Similarly, if you have policies, like a role binding, that gives permissions, but it doesn't really have a status of its own. It just tells the Kubernetes control plane, hey, here's a thing that should be granted. This is not in your CRD. This is a Kubernetes resource. But if you're writing a controller, you should know about this. Kubernetes has this notion of things called events. And they're objects. And it's a little weird to have an object that is an event, and it really says this thing happened at least once. You can see that somewhere over here there is a count of how many times it happened that is about one of your objects. So when you run kubectl describe, you can get a list of the recent events that have happened. And that means that your users can find out what's going on without having to read your controller logs, which is really great if they don't have access to your controller logs because they're only have access to one namespace or something like that. So if you are authoring a controller, think about what the events that are reasonable and relevant are. When there's a state change, you probably want to create an event. If there's no state change and you just checked everything, don't create an event. That'll put a whole bunch of noise on the API server. You can crash your cluster. It's a fun time. Done it. Needed to take out that controller and rebuild it to take out those events. Oh, and I don't know if I mentioned it before. These little things that have a little gopher down in the corner mean that you're going to need to get into the Go code, and it's probably going to be a more involved change. Some of the slides don't have the little gopher in the corner, and that is a change that's just in your custom resource YAML. And those are often easy to just drive by and say, hey, look, I helped. And this is one of those examples that doesn't have the little gopher over in the corner. There's some built-in roles that Kubernetes gives you. View, edit, admin. You can assign these to a particular namespace. So I can say, I'm going to pick on Josh in the front because I see him here. I can say Josh can view, you know, the resources in this namespace. And that's great. He can see all the pods and all the deployments and so forth. And then I deploy a Gateway API resource, and he can't see it because Gateway API isn't one of the things that Kubernetes knows about its permissions for. If you add one of these aggregate to view labels to a cluster role, it will build it into the view role. And then if you ship that, everyone who installs on the cluster who has view gets to view your custom resources the same way that they can view pods and deployments and don't get to view secrets. So view is not universal. Sometimes you're like, actually, you don't get to see these things. But by default, probably give people view or edit on your resources unless there's a good reason not to. You can also use the same aggregation mechanism to build your own custom roles. So Knative does this because we have a somewhat pluggable set of events. I bet Crossplane does this too, where you have a new resource type and you want to roll it up into some larger permission set. Aggregated roles is the way to do it. It's in the Kubernetes documentation. Read it. You'll be happy, or moderately content. And then this one, some people find controversial, but I found really, really powerful. There's a standard Kubernetes convention to have a condition that has a certain schema to it. And it says you should have some conditions. Let me give you a few more rules that I think will make you happy and will make people building a UX around your custom resources happy. First of all, have a top-level thing, a summary for humans or dashboards. Ready and succeeded are the two that I recommend. Ready if it's an ongoing thing like a deployment, and succeeded if it's something like a job. Finished is not a good choice because you don't know, was it a happy finish or an unhappy finish? Succeeded is real clear about, did I get to the place I wanted or did I not? And then all the other types use the same polarity. So talk about things that you want to have happen. So you can see here, we've got foo worked and bar fetched and I synced Baz. I don't know what those things are, but they're all telling me about positive things that I want to get to. And once you do that, you can automatically summarize in your controller, hey, anything plus a false means that I'm not ready because something went bad. A bunch of stuff that's unknown means it's still working. So if I've got some good stuff and some unknown, my overall ready status is unknown. If everything's green, great, it's green. And you can actually do this in your UI. You can show the little green dots filling up. And if something goes red, then you can show the whole thing is red. So Knative has a library for this, but you can do this on your own too. But if you do your conditions like this, machines can figure out because they can just say, oh, I'm looking for false bad, true good. When do I get ready true? And humans can look at it, and they can figure out what's going on. The reason that I recommend a positive polarity here, what I call it, true means good things, is when we started with Knative, we had a false polarity, and failed was the bad thing. And so what you wanted was failed false. And everyone who read failed said, oh gosh, it failed. When it said failed and then false, two bad things. And you put the two bad things together and you get a good thing. And people's brains don't work that way. So I encourage you positive polarity here. So now we're going to talk about not stuff that's in your CRD, but stuff that's around it. And the first thing is, think about, do you need a CLI at all? kubectl is pretty amazingly powerful. There's some fields in your custom resource definition that can make kubectl way more powerful. The first one is additional printer columns. So when someone does a kubectl get on your resource, you can control what extra information they get, and you can actually give them more information if they ask for wide format too. So you can say, oh, this is kind of a detail. This is the core stuff you really need to know. You can also add extra short names. So Argo CD, for example, their top-level object is called application. I don't know anybody who wants to type out application. Everyone wants to just say get app. So you can say app is my short name, but application is the full thing. Similarly, certificate, no one wants to type, so Cert Manager gives you cert as a short name. There's also a categories group. There's a kubectl get all that will list all your basic built-in Kubernetes resources. If you add your resources to the all category, they'll show up there too. And then when you say kubectl get all, you get all your HTTP routes from Gateway, and you get all your Knative services, and you get all your Argo CD apps all in one place. And if you forget to do it, you get like a third of your resources, and you're like, I know there's more here. What are they? And then you list all your API resources, and you have this huge, terrible script, and you're sad. I don't want you to be sad. I want you to be happy. That's why we're here. Happiness. Another thing that you can do, and this requires writing Go code and designing your stuff, is build aggregated objects. So you can see over on the left-hand side, you've got a Knative service is composed of a bunch of different stuff. And on the right, if you want to get a cert manager certificate, it will spawn a bunch of extra stuff. This top-level object gives you a thing where you can summarize stuff for your users. And you can see here, Cert Manager shows you, hey, the issuer and the certificate's up to date and all that nice stuff. And Knative gives you the URL and what revision is running and stuff like that. And then sometimes you do need to build a CLI anyway. So these are a couple of good cases I've seen. Sometimes there's a bunch of setup, and we'll talk about a really cool example in just a moment of getting a whole bunch of stuff done at once. And the other is giving people a friendly way to read the status and wait for something to be done. And if you're thinking about that second part, you should think as well, do people really want a command line, or are they really going to want a web page? And maybe you want to build yourself a little GUI for the second case. So funny enough, the second case is the one I did first here. When you run kn service create, it tells you what it's doing all along the way, and at the end, it prints out, hey, your URL is here. Go enjoy. And then Flux Bootstrap is really neat, because it will actually go and set up a repository for you and set up everything that you need to install Flux on the cluster, and then get Flux going, and then the files that are in GitHub will actually reinstall Flux over itself in the cluster so you can use Flux to manage itself. And I don't know how many of you have tried to set up this kind of thing on your own. I would fail that 8 out of 10 times. I know Kubernetes. I suspect most users would get a third of the way through and something would go wrong and you'd be debugging it. So Flux Bootstrap just gets you all the way there. It's orchestrating a workflow. And that's a really good thing to use a CLI for. And so now we're going to get into the kind of advanced cool stuff that you can do once you've got the basics down. So there's a bunch of types that are already in Kubernetes that are maybe close to what you're doing. Steal them. Use them. Object reference and label selector are a couple things that show up everywhere. Don't invent your own object reference. Don't invent your own label selector. Use the ones that are in Kubernetes. Everyone will know them. Similarly, there's a pattern. Knative has done a lot with it, but I've seen Crossplane and other things use it as well, called duck typing, where you have a bunch of different objects, but they all have a particular field that matches a common pattern. So if you look at a deployment, it has a spec and a template, and inside the template is a pod template spec. You look at a daemon set, spec, template, it's the same thing inside there. You look at a job, same thing inside there. You look at a Knative service, it looks the same. It's got a pod template spec and spec template. That's not an accident. We started differently, and then we realized everyone who knew Kubernetes pods had to relearn things. Why bother? And then we had to do more work to pass things through and copy them around. It's easier for people to say, here's this block, it moves over here. Borrow these things. It's the best form of flattery to the people who wrote them, and it will make your life easier. Another thing that I see people who are designing CRDs struggle with sometimes is zero values. And I'm going to pick on Knative a little bit here because they were just doing a talk about policy stuff, and they had some really nice use of zero values. So basically, zero is, I didn't fill this in Go. If you just use a standard int or a standard list or something like that, the zero value is the same as, I didn't bother filling this in. And you can use that to say, do the right thing. So they were designing permissions on, Knative was designing permissions on resources. And if you want to say, this permission applies to all the resources in a particular namespace, since this is namespaced, the target, you leave empty. That's a zero thing. And it says apply to them all. The other thing you could say is, oh, you didn't say apply this to anything? Here's a policy, and it applies to nothing at all. That's not very useful. Why would I bother writing a big old policy to never apply it to anything? Make your zero values useful, and your users get to write shorter YAML that's more powerful, and they get less surprise. So, and sometimes, this is a rule to be a little cautious with, but as much as possible, zero values are real cool. I think Go did a smart thing with their serialization and their defaults here. And you probably know what a good default is, at least as well as your average user. Otherwise, why are you writing the operator and not them? This is where you encode your knowledge of the system. And the last thing is something that is a little tricky. We didn't always get it right in Knative. I'm not going to say we are beautiful model citizens here, but Kubernetes isn't either, so there's that. GitOps. So we've used Flux and Argo both as examples. When you put a bunch of resources into Flux or Argo or Helm, there's a little bit of sequencing that they do around CRDs because they kind of have discovered that they have to. But for the most part, all the resources just get dumped into the cluster at once. And who knows what order they show up in. And if you're lucky, they show up in the right order. And if you're not, you're trying to create resources in a namespace before you created the namespace. And you get an error. And as much as possible, try to build systems that you can just reapply, and it will reach a state where it works, and it's not going to get in some weird half-initialized state, and then you're like, I can't go any further. Job is another example from the Kubernetes API, where you try to create a job and it already exists, and it's like, I don't know what to do. I don't know how I would have designed it differently, but if you can, try to build your system so that when you GitOps things in and you just throw a bunch of stuff in there, it works no matter what order you apply the resources. And this is a think hard type of thing. Sorry. And then this is the last tip I've got, and then I'll give you a checklist at the end so that if you're looking for the distilled version that you want to share with someone, it's coming up in just a moment. There's a couple different ways to interact with other people's resources, and they're good for different things. So labels and annotations are ways that you can put a little extra data on someone else's resource or find them. Labels are particularly good at finding things. So in this case, Cert Manager uses an annotation to find which issuer it is. If they used a label instead, you could make a narrower query to the Kubernetes API. You'd also be limited in the types of values you could put in there. They chose an annotation. I don't know if it was a good idea or a bad one. At this point, it's moot because it's there. You can use selectors on other people's resources to, again, use labels to find the right objects. And last of all, if you're creating resources, remember to set your owner references so that both garbage collection works and people can figure out automatically, hey, this was created by this other guy over here. If I need to change it, I probably need to go affect that guy. Otherwise, he's just going to set everything back to whatever whatever that controller wanted it to be to begin with. These are, again, they're all in the Kubernetes documentation, but I figured if I was talking about how to do this, it's worth explaining. Like, if you've got short values that you want to look up by, labels are the right thing. If you've got more detailed content, maybe you want a little JSON or something to give you control. Annotations give you that. Nginx Ingress famously has a whole ton of annotations that you can use to control the generated Nginx config, and it only occasionally blows up in your face. That's a place where labels wouldn't work, because labels are intended to be really short things that you can search on. And so this is the authoring checklist. If you're, looking to share this with people, I'm also going to be putting these slides on Sched as soon as I'm done here. You can share that around. I'm going to put it on my LinkedIn. But ask yourself these questions when you are authoring a controller. If you're working with a project and it's frustrating, look at this and see if you can feed a little bit of this advice, over there. You get to be a CNCF contributor. If you're not already, you can say, remember how I said I contributed to 10 plus projects? Stuff like this, go in and create an aggregated cluster role and send them a PR. Give them a little link to the documentation and explain why you're doing it. You are now a helpful and contributing member of that community. And you can put it on your LinkedIn, you can put it on your resume, contributor to projects X, Y, and Z. I'm not saying, you have to pad your resume, but if you're looking to get involved in the CNCF and you can write YAML, you can do some of this stuff. And if you're, more deeply into it, write some Go code. It's fun. And I didn't talk about it much, but upfront validation, there's a bunch of settings in both OpenAPI and Cell that let you validate a lot of the resources as they come in and give useful error messages back to users before the resource is even created. And so if you've got values where they should be in some meaningful range, maybe it doesn't make sense to spawn a pod with 64 petabytes of memory. You could, warn people ahead of time and say, no, I'm not going to do that. 64 petabytes is too much for anyone. And thank you. I'm happy to take questions and stuff. And this QR code takes you to the feedback on the talk if you want to tell me, hey, that was a great job, or gosh, you're an idiot, I want to hear what you think. Josh. I'll repeat.
Yep. Zero values. So
zero values.
Sometimes zero values are decide for me, but sometimes zero values are significant.
So the question.
Keep that from being confusing.
So the question is about zero values. Sometimes zero is actually a meaningful value, and sometimes it doesn't mean anything. If zero doesn't mean anything, I encourage you to think about what you could make it mean that's useful. If zero is a meaningful value, going back here to that slide, the thing I said no to over here with a pointer, if you use the pointer, then you can distinguish between null and zero. And that's what you should do. And then in your code, you have to write a little, if max idle time equals null, then da 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 da. Otherwise, if it's zero, do this thing. If max idle time is zero, doesn't really make sense. Like if it's a timeout of zero means as soon as you start, you have to stop. That doesn't, you could make that mean that, but it's not really helpful to users. So you can make it mean something useful. On the other hand, if it was number of replicas and scaling down to zero was a possible thing, like a deployment, then obviously you can't make zero mean run the right number. So yes, you have to be a little bit careful with zero. But where you can, take advantage of this, and where you can't, use the pointer version and make null and zero different and distinguishable. And I'm just going to put us back to this slide so that I get that tiny bit more feedback. Thank you. Anyone else has questions? I'm happy to, repeat and answer, amplify, agree, disagree. I do not promise to make up a limerick on the spot. Go ahead.
Is there a common library to manage conditions, or everybody implements their own implementation of it? Because I feel like everybody has their own library.
So the question is there a common library for managing the condition pattern that I described? Or is everybody doing it themselves? And the answer is sort of. Knative has a library for managing conditions in Knative dev package, and I forget exactly where it is under there, that a number of other projects use. If anyone wants to come talk to me, or I'm sure Dave is out here somewhere, Dave's over here in the audience, or any of the other Knative maintainers about putting that in a common place, A lot of people have borrowed that. Some people have rewritten it. I don't feel like it needs to be in Knative, but it needs to live somewhere. And if someone wants to find it a good home, I'm happy to help with moving it. And if no one wants to find it a good home, we're still happy to share. But we're going to version it for ourselves. So that's the incentive to stand up and say, no, actually, I'll help with this, is if you don't want our versioning.
Hi there.
And yeah, it was like 3 weeks of discussion to figure out that pattern. And it was actually the UI folks who were doing a GUI who drove a lot of it, who were like, hey, how do we show that this is getting ready? And it was like, well, you batch on this name and it goes this way and this name. And they were like, we can't do that. That's dumb. And eventually, I think it was Naomi Safer, was the person who said, hey, if we do it this way, then this will just work. And we all looked at it and we're like, wow, that's smart.
Hey, over here. Hey, can you see me?
Oh, yes.
I have a question. I don't know if it's really related to CRDs, but it's definitely related to operators. So
Okay.
At our company, we have kind of discussion going on, which is when we have a cluster with a bunch of CRs for a specific CRD, and we have our operator, and we now are going to create a new resource based on the CRs, right?
Yeah.
It can be a resource on another account, like in the cloud provider, whatever. And we have this discussion going on, which is what happens when we have hundreds or whatever CRs in this, and how the operator should do. Should the operator just go ahead and just check every CR and just change everything at the same time, hitting rate limits on whatever APIs? Or should we implement like a pool, a reconcile pool where we can do things separately? And I wanted to know your opinion on this, because at least at our company, it's a separating subject.
The question, if I can summarize it, is we have a bunch of custom resources that go out and work against some external API. And for example, when we start up our controller, how do we manage reconciling these hundreds of CRs at once and not going over rate limits? Is that about right?
Yeah, that's pretty much it.
So I have another Knative. We solved this answer, and I'm sorry for sounding like a smug guy, but we discovered this problem. And if you look in the Knative libraries, we do a little bit of inversion of control on the reconcile loop, and we actually run a two-lane reconciler. So what we found also was that when your controller's starting up and it's doing this big background pass, that can actually block you from noticing current events because you're processing through all this backlog. And so what we actually do is we have one queue for events that have just come in as changes and one queue for background scans. And the background scans is limited in its rate, and it's lower priority than changes that just came in through the watch API. And so we rate limit the amount of changes, but we also prioritize stuff coming in over watch over the background informer scan. And it's very complicated, but it seems to work fairly well. And that framework, I feel like, is fairly well tested. We had a test, and I think it's probably still there, that starts up the controller and does stuff in the cluster, and they're leader elected, and every 30 seconds it finds the leader and terminates that pod, forcing a new reconcile. And the rest of the stuff should still keep working while that's happening. And it does.
Great, thanks.
Come steal our goodies, they're good. Well, we've run out of time. I'm happy to keep answering questions, but I'm probably going to stop the mic in the presentation now.